Assalamualaikum and a very good day. My name is Effe Asmera and I'm from Universiti Putra Malaysia, UPM. So my final year project entitled The Study of Photoluminescence Characteristic of Palm Oil. So let's get started. As we all know that current LED light made up of rare earth materials such as bauxite and arsenite. So by the time this element will be gone forever, and also these elements are very expensive and very hard to handle. In the process of making and manufacturing this element, it can cause environmental damage to the river, forest and soil as well. So my final year project tends to solve this problem by proposing that we replace the usage of this element from LED and instead we use palm oil as organic material in the organic light emitting diode, OLED. So why is it palm oil? Malaysia is one of the biggest country that contribute the production of palm oil and also export it to the world. This can ensure the sustainability of palm oil production for OLED development. So, palm oil fruits produce the highest beta-carotene content compared to other types of fruits and vegetables such as carrots and tomatoes. In my study, I found that beta-carotene compound has almost the same characteristic as the organic molecule in the emissive layer of an OLED structure. So how can I verify it? Is that I use UV-vis spectrophotometer to analyze the absorbance, transmittance and the reflectance of this crude palm oil. I also received the crude palm oil from FGV itself. I also used another type of tested it using another type of oil such as Adela cooking oil, Caroteno cooking oil and also sunflower cooking oil. So here is the UV-vis spectrophotometer setup, and I will explain it very briefly. So as the light passes through the filter and monochromator, it will produce one wavelength, one specific wavelength that passing through the beam splitter and split into the two identical light, and the two identical light will be reflected and refracted to the reference, and the photodiode will capture the light and send it to the data processing. Then we get the graph of absorbance versus wavelength below here. So I will explain about this graph. So as we can see that from 300 to 700 is the visible wavelength region, and from 200 to 300 is for the UV region. In the UV region, we can see it's a very all type of oil absorb all the light in the UV region. This is due to the presence of double bond in each and every types of oil. But in the visible region, we can see that only crude palm oil and Caroteno cooking oil absorb light at region from 400 to 500 wavelength. This is because these two types of oil has color, has yellow to orange color. Here I show the sample of oil that I use for my UV-vis experiment. So we can see that CPO1 is the crude palm oil 1 has a very bright color as I use dilution series for my experiment. So in my experiment, I can see that the beta-carotene has a characteristic that can support my hypothesis that saying that beta-carotene can be used as the organic molecule in the emissive layer. Thus, beside we can replace the usage of the rare earth element in the LED. We also can increase the market price of our Malaysian palm oil. Thus, we can support our Malaysian country to become the very and it also can help Malaysia economy. So I think that's all from me. Thank you.